95% of the universe is invisible. We call it dark matter and dark energy, and almost nothing about them is understood. They are not small gaps in our knowledge. They are gaping holes at the very center of everything we think we know about physics. Here are 10 of the most haunting unsolved mysteries surrounding the two invisible forces that dominate our universe. Mystery number 10. What is dark matter actually made of? For decades, scientists have searched for a practical that does not seem to exist. The leading candidate was the WIMP, a weakly interacting massive particle predicted by the supermatery theory. Experiments buried deep underground, shielded from everything, have been listening for WIMPs for 30 years. They have heard nothing. Another candidate is the axiom, an ultra lightweight practical originally proposed to solve a completely different problem in physics. A third theory suggests dark matter could be primordial black holes, ancient black holes formed in the very first seconds after the Big Bang. The frustrating truth is that we have ruled out candidate after candidate and still have no idea what dark matter is actually made of. Mystery number 9. Why cannot we detect dark matter directly? Every experiment designed to catch it has come up completely empty. The Lex Zeppelin detector, a tank of liquid xenon buried a mile underground, was built specifically to catch dark matter particles. It has found nothing. Not because dark matter is not there, we know it is, but because it barely interacts with normal matter at all. This silence from our detectors is one of the most baffling results in the entire history of modern physics. Some physicists now question whether dark matter interacts through gravity alone, making it genuinely unacceptable by any instrument we could ever build. The more sensitive our experiment becomes, the more disturbing and complete the silence becomes. Mystery number 8. Does dark matter interact with itself, or does it pass through itself like a ghost through a wall? In the bullet cluster collision, dark matter sailed straight through the impact zone, suggesting it barely interacts even with other dark matter. But other galaxy collisions shows hints that dark matter may slow slightly, suggesting some kind of self-interaction does occur. If dark matter interacts with itself, it could form dark atoms, dark chemistry, and dark structure, completely invisible to every instrument we use. The stakes are enormous. A self-interacting dark matter universe looks very different from one where dark matter is a perfect ghost. Right now, the evidence points in both directions at once, and physicists are deeply divided on what it means. Mystery number 7. What is dark energy? We know it makes up 68% of the universe. That is almost all we know. Einstein introduced the cosmological constant, a kind of energy of empty space, and then famously called it his greatest blunder. Decades later, astronomers discovered the universe expansion is accelerating. Suddenly, Einstein's blunder looks like a prophecy. Dark energy is the best explanation we have, but whether it's a field, a constant, or something stranger entirely is completely unknown. In 2024, the DESI survey released data suggesting dark energy may not be constant. It may be slowly changing over time. If dark energy is changing, the implications for the fate of the universe are dramatic and deeply unsettling. Mystery number 6. Why is the universe expanding faster and faster? Dark energy is the answer, but the answer only raises more questions. In 1998, two teams studying distant supernova discovered galaxies were moving away faster than anyone expected and still accelerating. They expected gravity to be slowing the expansion down. Instead, something was pushing everything apart and getting stronger over time. This discovery won the Nobel Prize in Physics. It also revealed that our understanding of the universe is fundamentally incomplete. The expansion is now 2.5 times faster than it was 5 billion years ago. Whatever is driving it, it's winning against gravity. The universe is not just expanding, it's accelerating into something we have no name for and no theory to explain that. Mystery number 5. The Hubble tension. Two different ways of measuring the universe expansion rate give two different answers, and both appear correct. When astronomers measure expansion using the cosmic microwave background, the afterglow of the Big Bang, they got one number. When they measure it using nearly supernova and Cepheid stars, they get a number about 8% higher. The gap will not close. Both methods are among the most precise measurement in all of the science. Both have been checked and rechecked for decades. The disagreement is now so significant that many physicists believe it points to entirely new physics beyond our current models. The Hubble tension may have the single most important unsolved problem in cosmology today, and it has not solution yet. Mystery number 4. Will dark energy eventually rip everything apart, including atoms themselves, in a catastrophic event called the Big Rip? If dark energy continues growing stronger, at some point it will overcome every other force holding the universe together. First, galaxy clusters will be torn apart, then individual galaxies, the solar system, then planets, then atoms. In the final fraction of a second, even atomic nuclei and the protons inside them would be shredded by the invisible force. Whether this happens deeply depends entirely on the nature of dark energy, a nature we still don't understand. The universe might end not with a bang or a whimper, but with everything simultaneously torn to pieces by an invisible force. Mystery number 3. Did dark matter build the first galaxies? Evidence suggests it may be the invisible scaffold everything else was built on. Dark matter has gravity, and that gravity may have been essential to structure formation in the very early universe. In the early universe, dark matter clumped together first, creating gravitational wells that then pulled normal matter in after it. Without dark matter gravity, simulations suggest normal matter would have been too evenly spread to ever collapse into galaxies and stars. James Webb has found galaxies forming far earlier and far larger than predicted, possibly because dark matter halos grew faster than any model expected. The Milky Way itself may owe its existence to an invisible dark matter architecture assembled billions of years before the first star ignited. Mystery number 2. Are dark matter and dark energy connected to quantum mechanics, the physics of the incredibly small? Generally, relativity describes gravity and dark energy. Quantum mechanics describe particles. The two theories are fundamentally incomplete with each other. The theory unifying them, quantum gravity, might also reveal what dark matter and dark energy fundamentally are at their deepest level. Some physicists believe dark energy is a quantum vacuum theory energy, and the energy of empty space form quantum field fluctuations everywhere. The problem: when you calculate this quantum vacuum energy, you got a number 10 to the power of 120 times too large. This is the worst prediction in the history of physics, and fixing it may be the key to understanding dark energy. Mystery number 1. The most mind-blending of all. Could dark matter and dark energy be our first clue that extra dimension exists? String theory predicts gravity bleeds into extra dimension, appearing weaker than expected, which is exactly what dark matter mimics in our observations. If true, everything we have searched for is a shadow of something in a dimension we cannot see. So if this distorted your understanding of reality, subscribe and hit the bell. Comment your biggest question about this space-time. See you next week.